Okay, Q&A. These are questions from myself. Nobody's asked them me, but I figured these are things that I'm not only interested, but maybe somebody else is. So, what is the weight of the masonry heater? 340 bricks. PRT is in Finnish perusreikätiili. Each of them weighs 2.7 kilograms. That's 920 kilos for the bricks. Then we had some white bricks. Each of those are a bit heavier at 3.3 kilos, totaling 380. 18 bags of mortar at 450 kilos. Foundation stones and concrete maybe 240 kilograms. I don't know. I never measured them, but just offhand, I'd say they're above 200, below 300. And that's totaling 2 metric tons, i.e. 4.4 tons in pounds. So that's a lot of weight, and in fact it's such a load of weight that you really do need a good foundation. What design consideration for rocket masonry heater? Well, batchbox sizing. I already mentioned this, that only the length of the batchbox is flexible. The height and the width, are definitely not flexible. The thing about sizing a rocket mass heater is that you want to have a clean burn, and if the sizes aren't correct, you won't have a clean burn. So it's no use going around and toying with those measurements. Rather, you want to go and let the other guys do the measuring, unless you're, of course, experimental, and then go ahead and build different sizes and find out yourself. But the website that I linked to earlier is definitely a place to go and find out the specs for the sizing. But again, the length, that is the depth of the batch box, there you have flexibility. In terms of the batch box materials, mine were built so that the walls were firebrick, and I used clayslip for attaching them to one another. The ceiling is vermiculite board, 2 boards on top of one another, but you can also do a refractory mold or some other insulative material there. In fact, it would be more proper to build the walls also of an insulative material, so that you can really have the maximum heat possible inside the batch box. But my building consideration was that I'll just make the walls really sturdy, so I went with firebrick. The secondary air, the P channel, you want to think about the vertical part of it at the end, just as you go into the port that leads into the riser. That part will eat away, so you want to make sure that that pipe is changeable. How you go about making it changeable? My way was to just weld everything together, and at some point of time I'll just put a new part on it. But when you think about needing to take out the secondary air inlet, you really want to keep this in mind when you're thinking about the door for the batch box, if you have a door there. I mean, your thinking might be different. Maybe you want to have just bricks or something like that as a door, so they'll be easy to take out. But if you have a metal door like myself, then you need to make sure that you can actually take out the door and thusly remove the secondary air pipe. I know that they're looking at some alloys that don't actually eat away anymore. What those are and at what price, I can't say, but I'm thinking that just basic iron, as in my case, it's easy to weld for an idiot like myself who can't weld, and you know, won't go to any extremes there, just redo the part. The port has to be sharp. In other words, you want to create turbulence along the edges from the port into the riser. This is important because you want to have the gases mix completely and thoroughly with the air. So you have, first you have your primary air, which starts the burn in the batch box, and then you have your secondary air, which mixes with the fire gases just as they go from through the port from the batch box into the riser. So making those edges on the port smooth as silk, I mean, you'd think it would be good, but it's actually the total opposite. They need to be sharp so as to create turbulence. So keep that in mind. And turbulence is needed for the mixing of the fire gases with air. So that's the reason there. When you're building your riser, you want to keep in mind the fact that you can do a round riser or you can do a square riser. But if you do a square, then you have to think that the round, like in my case 180 millimeters or 7 inches, that needs to fit within the square. So like the corners of the square don't count. Think of it that way. So the round has to be what you start from with the sizing, and if you want to make it square, then the corners don't count. And it needs to be a square or an octagon, but it can't be like a what's the word for it, like a long where one part of the square is longer and one part is shorter. So it needs to be a perfect square or an octagon or whatever, hexagon, that sort of thing. But in my case, I went for a round one. Again, repeating the fact that you need to have 30 centimeters above the riser. More than 30 centimeters, in other words, more than 1 foot, is better. So if you can do 2 feet, you know, you're the winner. I didn't have space for it, so I had to do 30 centimeters, and I had to just live with that. But it seems to work, so no problems there. Outside the riser, you need proper insulation, because what you want to do is you want to create enough heat within the riser to create a full burn of the gases. And a full burn of the gases, once the system is going, once it's burning at full blast, you don't get any smoke out of the chimney. In fact, you mustn't get any smoke out of the chimney. That's the marker telling you whether or not it's working properly. You will have heat obviously dissipating, like in cold winter air. You can see the mirage of the heat while it comes out of your chimney, but you mustn't see any smoke there. If you're seeing smoke throughout your burn, then there's something wrong with everything. Now in my case, it takes sort of 15 to 20 minutes from igniting the fire to when it actually starts getting to the point where I can't see any smoke. So I guess that's a pretty typical figure, 15-20 minutes. Wouldn't know because this is the first one I've built, but this is what I'm understanding from what I've read. Also, what you want to be thinking about is that in the riser, the material needs to withstand 1000 degrees of that centigrade heat without decaying. So you do want to be sure that whatever you build the riser of, it needs to be good enough to withstand that. In my case, I took ceramic flue, what they use in chimneys, and I think that'll be good enough, but only time will tell, of course. The bell heat is most extreme at the outlet of the riser. This is something you need to be definitely thinking about. In terms of right above the riser, what sort of material do you want to have there? In my case, I put ceramic wool right there, and the ceiling part of the heater is actually the coldest part of the whole heater, weirdly enough. Now, that's because I put the wool there, the ceramic wool. It's a really effective insulator, but had I not, then that would be the hottest part. Now, the parts that are the hottest in my case is then just below the top of the bell. In other words, the brick area that is to the right of the riser, because to the left of the riser I have my chimney, and therefore the outer parts of the whole heater don't actually get hot there, or you can't feel the heat all the way to the surface, only to the right of the riser. Chimney flue, there you need the sizing guide for the channels within. That we already talked about. So in my case, the 180 millimeters or the 7 inches, that's the sizing guide. And any channels that you have within your heater, in other words, if you were to build some kind of bench or what have you, those channels need to be the same size as the flue if the way for your gases to go out are through that bench, and there wouldn't be any other channel for them to go. So keep in mind, wherever you direct the gas, it has to be the same size as the flue. Of course, if you divide it into two benches, then one half needs to be half and the other half needs to be the other half. So keep that in mind. They need to total to the same area as the chimney flue. Now the bypass for the chimney, if you have one, I don't, but if you were to build one, that can be smaller as long as you have other ways for the fire gases to exit into the flue. But a bypass needn't be the same size. One very important thing is, of course, the lowest part of the bell. What you want to do is have proper stratification of the gases, and the only way you will have proper stratification is by putting the exit from the bell into your flue as far down in the bell as possible. If you put it all the way up, you're just directing all of the heat directly into the flue, and that won't be a rocket stove for you. It's worthless. But if you put it all the way down, you will have ample time for the gases to flow through the bell and stratify there into different heights of heat, and then while they go downward they get colder and colder, and the coldest ones will then go through the flue out the chimney into the open air. and again 15-20 minutes into your burn, you shouldn't have anything else but heat left there. Unlike a J tube, secondary air is a must in a batch box. So if you're building a batch box like I did, keep in mind you do need the secondary air. I also already mentioned the fact that the larger the chimney, the flue, the bigger the bell. We looked at those sizes. So really ask yourself, do you want to create a monster, or maybe you are happy enough with a smaller size? So do keep that in mind, please. And when you're thinking about chimneys, you need to be able to sweep them. So the chimney sweep needs to have access into your bell and into your flue. That's a different, that is a must, at least in my country, let's put it that way. Yeah, well, actually, local regulations and fire safety and building code, we're actually getting into that now. So when you're building and when you're planning, keep in mind that you need clearances around and above hot surfaces. And at least in Finland, they actually talk about red hot surfaces versus hot surfaces and warm surfaces there. So you need different clearances for different grades of the hot. So please do keep that in mind. And those clearances need to be at doors, at access points, what have you. Chimney minimum height above roof level. Here again, there's an 80 centimeter minimum in Finland. So you want to keep that in mind if you're in Finland. If you're in some other country, do check your code. But the chimney, the highest part of the roof and the exit of the chimney, there needs to be an 80 centimeter rise of the chimney above the roof level. But it's not that straightforward. There are some exceptions, but keep that in mind. Also, the taller the stack, the more draft is created. In other words, how much draft do you need? What sort of climate are you in? So you don't want the heat to evacuate from the rocket stove. And what you want to keep in mind, for example, is that you need a baffle to keep the heat in the rocket stove. In other words, once your burn is over, you want to have a baffle to close and keep the heat in. And when you light the fire, the taller your stack, the more draft you will create, and the less bypass is a must for you, And also, when you're thinking about your burning season, if you burn daily or 3 times a week or something like that, your heater won't ever get cold to the point where it'll be difficult to light. But if you haven't lit it for a long while, then you might be in trouble getting the draft. So, keep that in mind when you're thinking about your build. One thing that I took as a given was that I wouldn't be building a brick chimney. Now, why would that be? There's a couple of reasons. One thing is that a prefab chimney is faster to install because there's no building there. And also, in terms of fire code, it's a no-brainer. And also, according to our building code, you're allowed to attach a prefab chimney to a built masonry heater. So what you can fix to a masonry heater is a prefab chimney of one type, but you cannot mix several types of prefab chimney. So you can't take one part from that and then one part from the other. They all need to be from the same manufacturer. But you can take one manufacturer's prefab chimney and attach it to a masonry, locally built masonry heater. So that's what I decided to do. And the other reason why I decided to do that was the fact that in a prefab chimney with really good isolation, you won't be actually getting any heat tied into that column running upwards. So when you're thinking about a properly built rocket mass heater, you want to keep in mind that where you want to have the maximum heat is in the bell and nowhere else afterwards. So any heat that you dissipate into the flue, into the chimney, is lost heat. And if you lose a lot of heat into the chimney, you will also create a situation where your rocket heater might not burn cleanly. It won't function properly. So you don't want to lose any heat into the flue, into the chimney. And a well insulated prefab flue prefab chimney was the other way of getting that to work like I wanted it to. Now, in terms of creosote and chimney fires, soot fires in another word, you need to have a chimney that is resistant to them. And the compliance here in Europe is a standard called EN 1856-1. And in Finland, you need to have a chimney of T-class 600, whereas a 400 would be quite enough in practice with a rocket mass heater. But, you know, compliance with code requires a T600, so you have to pay the extra for it. But then on the other hand, you know, better safe than sorry, let's put it that way. In terms of the foundation under the heater, you want to think about really well how much heat and weight the foundation can stand. You know, 2 metric tons of stuff is a lot of weight, so you cannot do that kind of build on a wood floor. You need to have real structure underneath, especially if you're going to be running a masonry chimney on top of your heater. I mean, the chimney itself might weigh 1.5 tons, 2 tons easily. Also, what you want to keep in mind that when you're doing the chimney outlet, normally you should be running only straight patches upward, but if you do need it, you can do a 30-degree run sideways, but not more than 30 degrees. So it needs to slant upwards all the time in the run. But even at 30 degrees, you might be getting draft issues with your riser, with your chimney. But, you know, keep that in mind that you can do some horizontal move with your chimney. And like I said earlier, a good pointer is to go to the attic before you start build. So make sure that you don't have any roof structures that would not allow for the chimney to run out. The chimney sweep will need access to the chimney, so you need to make a ladder and a roof access for the chimney, at least here in Finland. And what about insulating the batch box? Well, I should have done it, like I said earlier. and the dissipation of heat from it is always considered a no-no. But I decided against it. I didn't want to have the breaking of the walls, and so I did actually a insulation of the top of it and then of the bottom of it. So I figured that, you know, that'll be okay. And what about the bypass? No, I didn't go for that. In my opinion, none was needed. The thing is that in my build, the brick will retain the heat from one fire to the next. So every burning will always have some heat left in the system. Now, if I would have a metal bell, all of that heat would be rushing out of the system real quickly. But in case of a brick bell, it'll take time. And I'm thinking that the 150 centimeters of riser, remember I needed 130 and then 30 on top of that. Actually it's 160, not 150. But anyway, that'll have enough time for the gases to burn well and burn them into good heat. And when they mix nicely inside, I have a lot of heat in the bell. And my chimney entry point, this is a very important consideration. My chimney entry point is such that to begin with, it's actually inside the bell and far down in the bell, so it's as far down as it could go. And this means that the chimney, the wall which is inside the bell, is actually part of the hottest part of the whole bell, which will actually in practice mean that it'll heat up real quickly and it'll create a quick and strong draft. So I wouldn't have problems with the draft, I figured, and that is exactly what has happened. There is a good draft, has been every time since last fall. Also, my total length of the flue is 5 meters. That's sort of 16 feet. And that already in of itself creates a good draft. And again, I burn several times weekly when I burn, so there shouldn't be any problems from burn to burn. And how long did it take to build? Well, as I noted already, not quite daily efforts from September 19 to November 22nd. And the actual bricklaying started on November 4th when the bricks arrived. Up until then, I did just the fixing of the places, started with the foundation. And during the build, I used a lot of time on YouTube for watching things and how to do them and getting tips and tricks from other people. So 50 days was the total build time. Whether or not it's a long time, I don't know. For me, it was a lot of work and a lot of learning in that time. I want to mention some resources online. Stove Chat from Matt Walker, definitely a good resource. These are, by now I think Matt has done 40 1-hour lengths, and they're definitely worth the while. So do check them out if you want to learn and learn from the best, I would say. So, you know, as you can see, I watch them regularly. The other resource is batchrocket.eu. I already showed this earlier. And the third resource I want to mention is Donkey Board. A lot of info there, and good info. So these are the 3 that I want to mention if you're just getting started like I've been. Excellent information, a lot to read. It'll take a lot of time, but so worth the while, so worth the time. Anyway, it's just above an hour now, so I do want to take the thanks. You've been good sports looking at my info for this long. I do hope that I could help you, and good luck with your own build. This is Sakut chiming out. Take care, guys. Bye bye.